video, I'll be walking you through two Java programs I've written to apply key object-oriented programming concepts. So let's start with a myInteger program. The myInteger class encapsulates an integer value and provides methods to check whether the number is even or odd, compare values, and work with integer objects. This is a great example of encapsulation and static methods in Java. In this program, we define a class called myInteger with the following key components. So first we have the instance variable, aka value. This stores an integer inside the object. It is private, following encapsulation principles. And then we have the constructors. We have a no argument constructor that sets a default value. We also have a constructor that accepts an integer and assigns it to a value. And then we have the getter method. This allows external classes to retrieve the stored integer without directly accessing the variable. And then we have the instance methods. So this is the is even and is odd check whether the value is even or odd. And then we have the static methods. So the is even int and is odd in allows us to check numbers without creating an object. The is even myInteger and is odd myInteger do the same, but take a myInteger object instead. And then we have the equality check methods. So the equals int and equals myInteger compare values for equality. And then we have the main method for testing. So this is where we create instances of myInteger and test all methods, printing the results to verify that everything works correctly. When we run myInteger.java, the program creates instances of myInteger, calls different methods, and prints whether a number is even, odd, or equal to another number. By using both instance and static methods, we gain flexibility in how we check integer properties. So now we're going to run the program. So this is the first output, and as you can see, we already have some values defined, like we have the 5, the 8, and then the 6 and the 5. So now we're going to change these values. So now you can see the new output for the values that I just changed. And I'm going to try one more output now. And this is the third output, and as you can see, these yield the correct outputs. So now for question 2, we have the triangle class, which models a geometric triangle. This class extends geometric shape, meaning it inherits properties like color and whether the shape is filled. In triangle.java, we define the triangle class with the following elements. So first we have the instance variables, side 1, side 2, and side 3. These store the lengths of 3 sides of the triangle. Default values are set to 3.0, 4.0, and 5.0, which is a right triangle. And then we have the constructors. So there's a no argument constructor which initializes the triangle with default sides. And then we have another constructor which allows us to create a triangle with custom side lengths. And then we also have accessor methods. So these return the values of side 1, side 2, and side 3. And then we have the perimeter calculation. So this adds up all 3 sides and returns the result. And then we have the area calculation, which uses Heron's formula. And the Java math.square-root function computes the square root. And then we have the toString method, which returns a formatted string with the triangle side lengths. And then we have the main method. So this is for user input and testing. So the program prompts the user to enter 3 side lengths, a color, and a boolean for whether the triangle is filled. It then displays the triangle's area, perimeter, color, and whether it is filled. When we run triangle.java, the program waits for user input, creates a triangle object, calculates and displays its properties. This demonstrates object-oriented programming, inheritance, and user interaction through the scanner. So now I will show 3 different outputs. And now I will try a second output. And now I will try a third output. So to wrap up, we explored 2 Java programs that introduce object-oriented principles. So the myInteger showcases encapsulation, static methods, and comparisons, and Triangle builds on inheritance and mathematical calculations. This assignment helps transition from C++ to Java by reinforcing familiar concepts. And that concludes my video. Thank you so much for watching.